So this is the FutureWatch presentation. We're going to talk about news from Imperas. We'll also talk a little bit about just who Imperas is, and RISC-V as well. So why don't we just get going and start about RISC-V. RISC-V, as you're aware, is a instruction set architecture. It's flexible, it's extendable, and it's that freedom and not the free. That's why RISC-V usage is growing so fast. Regarding Imperas, the Imperas founding team, by the way, my name is Larry Lapidus. I'm Vice President Worldwide Sales for Imperas and part of the founding team. Our founding team has a background in electronic design automation tools and FPGA and processor IP companies. We founded the company in 2007, seeing a need for tools and methodology similar to EDA for software debug, test, and analysis based on software simulation. So this required high-quality models of the embedded processors such as ARM, MIPS, and Renesas. We self-funded the company at that point and built this business on virtual platform products. In 2016, we realized that the RISC-V community would need RISC-V models for software development. Okay, there's going to be another processor architecture. Let's go and do the thing that we know how to do. So while there was and still is a large demand for RISC-V models for software development, there is also a need for models of custom RISC-V cores and a need for verification of the RISC-V cores. Imperas started by working on RISC-V compliance and then on processor verification with the RISC-V International Organization and the Open Hardware Group and customers such as NVIDIA Networking, NSI Texi, MIPS, Ecosystem, Silicon Labs, and more. We also developed the RISC-V OVP Sim+ instruction set simulator. We made that freely available, supporting RISC-V processor design verification for the complete RISC-V specification. Now, Imperas RISC-V processor models are used in almost every RISC-V project, whether with the free RISC-V OVP Sim+ or with the Imperas commercial tools. And as we look at the RISC-V customers and partners, we go down that list of customers that I was talking about with NVIDIA Networking and NXP and Silicon Labs and Nagravision, Dolphin Design. There's a long list there, a lot of them that we can't talk about publicly. On the processor IP side, we're partners with most of the processor IP vendors. Andes, Sci-Fi, Ecosystem, Geisler, Imagination, Intel FPGA, MIPS, Microchip, NSI Tex, Open Hardware Group. And we're partnered with the tool companies. And two last things here. One is there are numerous universities around the world that are using Imperas models for RISC-V research and for RISC-V-based courses. And the second thing is that free RISC-V OVP Sim+, there are more than 100 different organizations that are using the free RISC-V OVP Sim+. In terms of the technology that we have, it's based on the processor models. I've talked about we started with virtual platforms and models of embedded processors like ARM and MIPS. So this processor modeling technology has actually been developed over the last 15 years and hundreds of man-years of effort. Here with RISC-V, we have a reference model that supports the full specification for RISC-V, both the ratified specification and the stable unratified piece of it. This is fully configurable. There are more than 250 different parameters that users can set. And then there's this extension library capability. So using the same APIs that Imperas uses to build the reference model, users can extend the the model to add custom instructions and CSRs. That gets used first in a design verification environment. So here what we have is this reference model, and then verification IP in these places, and then some standards here, the RVVI, RISC-V verification interface standard, and then the system Verilog test bench with the device under test, the actual RTL here. And what this does is to provide a standard interface, verification IP, and the reference model for doing DV of the RISC-V cores. So that's one use case that we have. And then the second use case is back to that software development use case. And this is the virtual platform environment. You see the, again, the RISC-V CPU models in here, able to model not just the CPU, but actually a full SoC, peripherals and memory and buses. And then we have the simulation engine and tools, the multiprocessor debugger and verification, analysis, and profiling tools. So I mentioned the models. And again, this base model supports the full specification, user configurable for extensions, for which version of each extension, and all the implementation-specific options as well. And then Imperas provides a methodology to easily extend the base model. And the nice thing about this architecture here is that any customization that is done is outside of this base model. So all those 100+ users using the free RISC-V OVP Sim Plus, all the Imperas commercial users, all those people are using this base reference model. That means lots of people each day are beating on that and making sure that the quality of this reference model is as high as it can be. So when you're adding custom instructions, you do that separately, so it's a lot easier to maintain. And also, that user extension source can be proprietary. The model here is open source, but the user extensions can be proprietary. That's a nice little twist there. In terms of adding custom instructions, Imperas has developed this flow to help our users add custom instructions. The interesting thing in the RISC-V world is that in terms of adding custom instructions, it's usually done from a domain-specific perspective. So users want to develop a domain-specific processor. So the new instructions are going to be added in order to optimize a specific application or a set of applications for that domain. So the first thing you want to do is to characterize the C application using the Imperas simulation tools, using trace debug capability and function profiling along with other tools, and then develop the custom instructions and then redo the characterization of the new instructions in the application. And you can go ahead and iterate that path until you get the custom instructions to where you want. And then you can optimize and document the model, do some additional testing of the model, get instruction coverage, line coverage data on that, and then go ahead and release and deploy the model. So this is a path that list of commercial users has all taken with Imperas, because every one of our commercial users is doing something custom with the RISC-V model. That's the exciting thing about RISC-V. Again, it's the freedom to be able to innovate with RISC-V. That's the exciting piece. So going back into that design verification use case, so again, this is the RISC-V processor DV flow. And the key technologies are the reference models and the verification IP. So that's the nice thing that we've done. We've been working on design verification now for, I think, about 4 years in the RISC-V community. And going back to the beginning of Imperas and our founders coming from EDA, our founding team actually worked on RTL simulators, worked on design verification in RTL. So actually, this is sort of a back to the future moment for us, and it's actually fun. So here we see the environment, the reference model, the verification IP, the RVVI standard for interface. We see customers that are adding these unique instructions, and you know, whether it's the unique instructions, whether it's even within the RISC-V specification itself with things like interrupts, or even adding a multi-issue or an out-of-order pipeline, the feature selection and design choices require serious consideration due to the implications of every decision, and those implications really impact the verification task. So every addition dramatically compounds the verification complexity, adding schedule, adding resources, quality, costs, and these are risks. Before 2021, there was no off-the-shelf toolkit or products available for DV of processors. RISC-V or not, there was just no processor DV products. We introduced Imperas DV a year ago at the RISC-V Summit, and now this is, I think, the de facto standard for DV in the RISC-V industry. So with the reference models, with the Imperas DV verification IP, with RVVI, this means that there's support for asynchronous step and compare DV flow. This is needed, this flow, different than a trace compare flow where you're just comparing what an instruction does. This flow is needed to support features such as interrupts, privilege mode, debug mode, multi-heart, etc. So that was one side of the use cases. The second side is the environment for software development and architecture analysis. This is the virtual platform side of things. Again, we've got a load of models just in the RISC-V community. We support probably 125 different RISC-V variants specifically for processor IP vendors. And then we have the models with the custom instructions that we or our customers have been working on. The simulation engine that we have is very fast, hundreds of MIPS performance, hundreds of millions of instructions per second. And then we have the tools available there, the debugger and the software verification analysis profiling tools. And the nice thing here, while the early projects in RISC-V, going back, say, 4 or 5 years to NVIDIA first putting RISC-V cores on their GPUs as control processors, those were sort of small things, but now we're seeing real embedded application processors, a lot more complexity in the RISC-V community. And so virtual platforms provide a development environment with controllability, with observability, with determinism, with the ease of automation, ease of delivery, ease of maintenance. There's shift left for the software schedule, and the software schedule is often the critical path to product delivery. And performance, which enables comprehensive testing of many, many scenarios. Because on the architecture analysis side, in a given domain, you want to test a large number of scenarios to make sure that you've actually optimized the custom instructions, the CSRs that you're adding to the design. So virtual platforms are a must-have for any system, any software of any complexity, or in any system with quality, reliability, safety, or security requirements. So that's a brief overview of Imperas. We wanted to talk a little bit about news here, and so what I wanted to comment on is first a couple of presentations from Imperas and partners, and then announcements that we've made in the last couple of weeks, and actually this morning, and one coming tomorrow morning. So NSI Texi is a subsidiary of Denso. This is from a presentation that NSI Tex did at the RISC-V Tokyo Days conference about 3 weeks ago. They're building here with the NS72, they're building a RISC-V processor and licensing that processor. Here they're building a performance estimator for that using Imperas CPU dev products, our virtual platform products. So they're simulating this and simulating pipeline, bus throughput, and latency. And given that one of their target markets is automotive, being able to do performance estimation for a use case where worst case timing is an important thing to know, this is actually a really good thing. NSI Tex also uses Imperas for DV and software development, in addition to the architecture analysis with a performance estimation. Last week in Munich with DVCon Europe, we did a joint paper with Dolphin Design. Dolphin Design is developing DSP subsystem IP based on RISC-V. This is their Panther DSP product. You can see it's got multiple RISC-V cores there. And so we've been working with them and also with the OpenHW group on verification of the OpenHW CV32 E40P v2. They also need performance estimation and software development using virtual platforms. So in this presentation at DVCon, we talked about using the asynchronous step and compare with the Imperas DV products. We talked about virtual platforms with software, the software simulation technology. And the key thing here is that the same RISC-V processor model can and should be used for both DV and software simulation. And this is what Imperas is enabling. On the news front, this is a list of announcements that we've made recently, starting with the Andes announcement. We've been working with Andes for, I was just looking this up going in here. It's been 5.5 years of collaboration with Andes. They were the first processor IP vendor that we started working with. We have a number of joint customers with them. We made an announcement with OpenHW Group. Simon Davidmann, our president, CEO, is chairing the verification task group. So again, Imperas driving RISC-V processor DV methodology. Announcement with MIPS using us for DV with an Imagination, where we're providing models of the Imagination RISC-V processors for use in virtual platforms. This morning there was sort of a roundup of Imperas DV capabilities, but also there was some new news in there, specifically talking about the functional coverage libraries that we've released just last week through GitHub to support RISC-V design verification. And then tomorrow morning we'll make an announcement regarding NSI Tex, where they've qualified the Imperas RISC-V models of their new Acaria processor product line, the RISC-V processor line. So there's some nice graphics that you'll see for each of those announcements. So we've got all this news going on. You're going to see Imperas quite a bit at the conference this week. There's a party this afternoon after the general member meeting, just right out in the, just past the registration desks there. We've got keynotes, we've got other presentations in the technical tracks and in the expo hall. So we're looking forward to seeing everyone there, answering more questions, giving more detail. Our customers see our key technologies, the various tools that we have, the simulator, the libraries of the processor models, the DV methodology, and the verification IP. And the Imperas RISC-V solutions enable complete RISC-V processor verification. They enable comprehensive software testing. They enable schedule reduction. And this is why most RISC-V processor projects are using Imperas. Thank you very much. I'm Larry Lapidus. You can find me there. You can find me around the conference this week. I've got a few minutes left here, so if anyone has a question right now, I'm happy to answer that, or we can go refresh our coffees and get ready for the next one. Yeah, thanks. Oh, good question, Kevin. So the question was, how many designs do we see that use custom instructions? Well, we've got I don't know, 20 to 30 different customers that are using our commercial tools. Every one of them, so that's just on the RISC-V side. Every one of those is using custom instructions. Some not so many, some a little bit more significant. So the 100 plus that are using the free tools mostly are doing things within the RISC-V specification, or the custom work they're doing they think is not really significant. So I probably in that 20 to 30 range, but everyone that's using the commercial tools. Yeah? The ISS, the RISC-V OVP Sim Plus is available from our Open Virtual Platforms website. So we have the Imperas website, imperas.com. We also have ovpworld.org. And if you go to ovpworld.org/RISC-V, it will lead you to the RISC-V OVP Sim Plus. And yes, that's a free download. Yeah. So the question, if I heard correctly, the question is, can the virtual platform help with side channel analysis and other security issues? Yes, is the answer. It depends exactly what you're doing, but we do have customers using us in various security applications. And with the virtual platform, you can do a couple of things. One is to build models of peripheral components. So if you're doing something else in the security space that is not directly processor related, you can build a separate model for that. And then we have the analytical tools. And the analytical tools allow you to do things like add in assertions or protocols. So you could do simple example, but you could, if you have a shared buffer with a lock-unlock protocol for that, you can set an assertion to check that that protocol is followed. So there are various side channel things that you can do. And actually, we have some defense industry customers that use the virtual platform to do security analysis because it's a nice, safe environment where you can test out various attack threats.
Just following up on that, a lot of the side channel attacks are very hardware oriented, power glitching and detecting emissions and things outside the chip. I'm assuming that what you can check stops short of that, right? If you don't have a hardware model.
We don't have exact models of the hardware, but for example, we were working with one research lab that was doing things to, they were actually adding custom instructions that were not, that were being executed, but with just fake data. So just sort of randomly inserted into the instruction stream as a way of defeating side channel attacks. So you could actually look at the instruction trace, and you could do some power estimation based on that to try and either randomize or even out the power signature to defeat a side channel attack. So you would still want to test on the hardware, but this gives you a pretty good start. So thanks, everyone. We'll wrap it up here. Thanks for coming, and we'll see you around the show. Have a great show.